Hello everyone, Mr. Fawcett here, and we are back with another geometry lesson. Today we're going to talk about two shortcuts that students try to use, but they actually don't work, so they're not valid. Currently we've talked about 5 different shortcuts for proving triangles congruent. Right? We have SAS, we have SSS, we have ASA, we have AAS, and we have HL. Now, there's 2 others, again, that sometimes students write down in proofs, but we're going to show you today why they don't work. So hopefully, after today's lesson, you won't make the mistake of trying to use them to prove triangles congruent, because the math doesn't hold up behind them. Before we get going, though, let's take a look at these 6 triangles, and I want you to determine what congruence criteria you could use, what shortcut you could use to prove them congruent. If you're unable to prove them congruent, just write unable to determine congruency. All right, so for number 1, we have 3 sets of sides that are congruent. So that's going to be an SSS. For number 2, and I say number 1, but they're not labeled. Let's label them. So for number 2, we only have 2 sets of sides marked congruent. However, we should pick out these vertical angles right here, which would allow us to have SAS. So sometimes it's given, but it's not directly shown on your diagram. So you may have to do a little bit of outside the box thinking. For 3, everything is given that we need. That's going to be SAS, 2 sets of sides, and an included angle. For number 4, we have 2 angles and 1 side. The side is outside of the angles, so it's going to be AAS. For 5, we have a right triangle and a hypotenuse and a leg from each triangle that are congruent, so that's going to be HL. And for number 6, we have 2 sets of sides and 1 set of angles that are congruent, so that's going to be SSA. Well, wait a second. No, that's not a shortcut, right? So this is a mistake that students make a lot. They think that we have AAS, so SSA also works, but it doesn't. And we're going to show you why later. For this one, you would just write unable to determine congruency. Okay, because SSA is not a valid form of triangle congruence. All right, let's take a look at why these are not valid forms. First thing we're going to start off with is the AAA criteria. So this is a criteria that students sometimes use. It stands for angle, 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 but we're going to see why it doesn't work. We've already talked about it, but we do have 5 congruence criteria that would go in the blank here, 5. All right, if I had a whiteboard in front of you, I would have the angles up there, but I don't. So I'm going to go to the back of these notes where I have a clean sheet of paper so I can draw freely. There we go. So I'm going to have one triangle like this. It doesn't have to be a right triangle. It's just drawn that way. And I'm going to have another triangle that sits inside of it. And the way that's going to happen is that these lines are going to be parallel. Okay, and then the rest of my triangle is going to look like this. So I think it's clear that these angles right here are congruent, right, because it's a shared angle. Now, these angles right here, well, I could say those are congruent because they're corresponding, right? We have 2 parallel lines here. If I extended them and drew in the rest of the diagram, those would be corresponding angles. Same thing with these angles here. Because those lines are parallel, these angles are going to be corresponding. So I have 2 triangles with 3 sets of congruent angles, but they're clearly not congruent, right? The sides are not the same. So this is the only counterexample I really need to show you, right? Because if that criteria breaks down at all, right? If AAA, angle, 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 doesn't work in every scenario, we can't use it as a shortcut. So this is your counterexample. It's possible to have two triangles that have the same angle measurements, but they are not going to be congruent because their sides do not have to be the same. All right, let's go back up here. We'll finish off by reading this top paragraph. So angle, 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 or AAA, does not guarantee congruence because it does not provide enough information, like we just showed below. It doesn't tell us anything about the sides. We can have two triangles with three sets of congruent angles, but their sides may not necessarily be congruent. This is a good example of when the converse of a conditional statement is not necessarily true. And I'm talking about this statement right here. If two triangles are congruent, then they will have three sets of congruent angles. Well, that conditional statement is true, right? If the triangles are congruent, their angles have to be congruent, right? Just like all their sides have to be congruent. Corresponding sides, that is. But if I reverse this, right, if we call this P and this Q, and right now this is P implies Q, if I do Q implies P, where I say if two triangles have three sets of congruent angles, then the triangles are congruent, well, that's false, right? So that's what they're saying when, or that's what I'm saying when I wrote the converse of a conditional statement does not always have to be true. In this case, it isn't. Let's talk about SSS criteria. So the easiest way to remember that or did I say SSS? I hope I said SSA. SSA, the easy way to remember that this is not something we're going to use, right, is because if you read it backwards, it's not going to be a word we would ever use in class, right? So there's always a few chuckles when you teach this. The students recognize that if you read it backwards, it would say something that, would be inappropriate to say in class. So that's the easy way to know that you're not going to put it in a proof, right? If you're not going to say the word out loud in class, don't write it in your proof. We want to be a little bit more mathematical than that, though. So let's talk about why it doesn't work. I'm going to go down to a blank sheet of paper because I want to draw this myself. Have a little bit more space. Let's say I had a triangle like so. And let's say this triangle had angle, well, we don't even have to say the actual angle measurements. We'll just put some marks there. So that's one of the triangles. Now, my other triangle, pretend that I just took this side right here and just swung it over here, right? So it ends up being like this. So this segment right here, congruent to this segment right here, okay? And let me just draw the entire purple triangle. Oops, that's my eraser. So I have this purple triangle, and I have the larger black triangle. Well, they both share the red angle, right? I think we can clearly see that. And they both have one set of congruent sides. Now, they also share another side, right? They share this side right here. So I can put two tick marks here. So now I have two triangles where they have two sets of congruent sides and one set of congruent angles, but they're clearly not congruent, right? The purple triangle is clearly smaller than the black triangle. So again, this is just like one counterexample, and that's all you need, right? It's possible to draw two triangles that have two sets of congruent sides, one set of congruent angles where the angle's not in between the sides, and the triangles do not have to be congruent. Again, if you missed this diagram, pause the video, rewind it, go back again to see how I drew it, to understand how I knew that these two sides right here could be the same, right? It's obvious to know why this side is congruent to that side because they're the same side, right? They're the shared side. This angle is a shared angle. But if you're wondering how I could put tick marks here and here, just go back and rewind the video and make sure we have a full understanding. All right, so there's your counterexample. Let's go finish off why this is not a good criteria. Essentially, we could just do the same thing up here. I just wanted to draw the diagram from scratch to make I think it was easier for you to see. But essentially, right, if you took this segment right here and swung it across, you could have this piece also be 9. And then you'd have the red triangle and the blue triangle. They share that 23-degree angle. They both share the 11 side, the side marked as 11, and they both have a side that is 9, has a length of 9. So again, they fit SSA, but they're clearly not congruent. So again, take note that for SSA, the angle must not be between the sides. Otherwise, we could say that the triangles are congruent by SAS. Okay, those are the two that are not going to work, so make sure we never use those in a proof. The rest of this lesson is just practice. So it's a bunch of different proofs. Again, you have 5 different shortcuts that you have the possibility of using. So make sure you're thinking about what sides and what angles you've proved congruent so that you choose the right shortcut. We're going to go ahead and do 2 of these for this video. We are going to start with number 1. So pause the video, see if you can understand what reasons need to go with those statements, mark up your diagram as needed to eventually get you to that conclusion using one of our shortcuts. All right, so it says angle RAP is congruent to angle RBP. These are not marked. And I don't know that these are right angles even though they look like it, so I'm just going to keep them as single arcs. And it says that segment PR bisects angle APB. Okay. We need to prove that triangle APR, we'll do that in orange. Not the best. APR is congruent to angle BPR. All right. So that first statement is our given. And I know one set of angles being congruent, so little a. Then it says measurement of angle APR is equal to the measurement of angle BPR. Well, let's first label those on our diagram so we know exactly which ones we're talking about. APR, be up here, and BPR right below it. So why would those 2 angles have the same measurement? Does it tell us anything maybe in the given or up above in our proof that would let us know that? Or is it how the angles are positioned? Well, it does tell us that segment PR bisects that big angle APB, right? That big angle being this one. So if a segment bisects an angle, well, it means it's going to split the angle into 2 equal parts. So we can say definition of angle bisector, because the angle's being bisected. A segment is not being bisected. The angle's being bisected. If I know that the angles have the same measurement, I can say that they are congruent by the definition of congruent angles. And here's another little a. Now, I will tell you that sometimes you'll have this step taken out, right? So you may just have this up here, and you would just say definition of angle bisector for why the angles are congruent. However, you could see it written like this, and then you may have to use the definition of congruent angles to get to the actual congruent statement. So that's why I had both of those here, just to make sure you knew the definition of congruent angles property as well. let's keep going. It says segment PR is congruent to segment PR. It's congruent to itself. Well, anything that's congruent to itself, I'm going to mark it on my diagram first, but that's going to be the reflexive property. Of congruence, because it is a congruent statement, not a equals, or not an equation, rather. This is going to be a little s. So I have two a's and an s. That should be enough for a shortcut. We just have to determine which shortcut it is. Is it ASA or is it AAS? Well, let's look at whether or not the side is in between the angles. And it's not, right? The side that's in between the angles would be side AP and side BP, but those are not the ones ticked off. It is side PR, which is outside of the angles. So this is AAS. And we're done. Let's do one more. Go to number 3. Make it a little bigger for us. We're just focusing on that one. All right. So again, pause the video, attempt this one on your own, then come back and listen to the discussion. So for this one, it just gives us two sets of parallel lines, right? It tells us line AB is parallel to line DC. And I'm just going to put some arrows on here because they don't give them to us. So AB parallel to DC. And I know that AD, well, you have to use two arrows, is parallel to BC. So I have to prove everything else just based on that. And I need to prove that triangle ADB in orange is congruent to triangle CBD in green. All right, let's see what shortcut we can figure out. First statement's given. Then we're told that angle ADB is congruent to angle CBD. ABD, this angle right here, is congruent to angle CBD. Sorry, I marked the wrong angle. What am I doing? There we go. ADB over here is congruent to angle CBD right here. Well, the only thing we have to work with is those parallel lines. And whenever we have parallel lines, there's numerous angle relationships that are available to us. However, there's only a few that say the angles are congruent, right? Because the other relationships say the angles are supplementary. So we can have corresponding angles, those are congruent. And then we can have alternate interior or alternate exterior. Well, if we look at these parallel lines, I'm going to use these two right here, AD and BC, right? Those angles are inside the parallel lines, and they are on opposite sides of this transversal. So they're going to be alternate interior, and we can use the alternate interior angles theorem. That's why those two are congruent. Let me get rid of those parallel lines. Again, you can always pause the video and look at the diagram a little bit more in depth if you need to. It now says angle ABD, which is the one I had originally marked. ABD is parallel to CDB. So those are marked with two arcs. Well, again, we only have to work with the parallel lines. These ones are using the, oops, it's my eraser. These ones are using the other parallel lines. So I'm actually going to, still on my eraser. What am I doing? There we go. So you have a parallel line here. Parallel line here. And my transversal is right here this time. So again, those angles, they're on opposite sides of the transversal, and they're inside the parallel lines, just like the other ones. So again, alternate interior angles theorem. All right, so we have two sets of angles. we can mark these, little a, little a. But I do need a side, right? Because AAA is not a thing. It doesn't prove anything congruent as far as triangles go. So they give me a side, BD and BD. And those are the two sides right in the middle here. They're the shared sides. It's going to be the reflexive property of congruence. And little s. So again, we have two A's and an S. Is our side in between the angles? Can we use ASA or do we have to use AAS? Again, it's important not to just go by how it's written down the side, right? Down the side, it says AAS. But we could have proved these in different orders, right? I could have proved these two statements in reverse order, right? I don't need one before the other. So you can't go by how it's written down the side of the proof. You need to look at the actual diagram, and that's why it's important to label. And we can see that the side, BD, is between those sets of angles. So this is going to be ASA. All right, that's going to do it for today's lesson. There are some other proofs to work on, as well as one other application problem below. We'll go through some of those in class. If you want to get a head start, you can before then. But as always, enjoy the rest of your day, and I will look forward to seeing you next time.